So we are actually starting 8.3 today. And we could go through the book, but then again, we already went through Desmos yesterday and we investigated this parent graph y equals 1 over x. Here it is, y equals 1 over x. And we also talked about the asymptotes that exist right here. In this case, the x-axis is an asymptote, and also the y-axis is an asymptote. And we should know what an asymptote is. It means that your graph forever approaches it, but never actually gets to it, right? So we also messed with Desmos yesterday and investigated what happens when we change this parent graph by adding a 1 out here. Or what happens when we change the parent graph by adding a 1 in the denominator. Or by adding any number out here, or subtracting any number out here, or adding or subtracting any number down here to x. And we should have recognized or come to the conclusion that this shifts your graph up or down. And that this value right here, the opposite of this value right here with x, shifts your graph left and right. So I want to associate that or relate it back to vertex form parabolas. That's y equals a parentheses x minus h close parentheses squared plus k. Okay. So your a value tells you if it opens up or down. Also, if it gets vertically stretched or compressed. Your h value is always with x, and you always think opposite of what you see. And your k value is always on the outside by itself, and you take it for what it is. So what we should have concluded yesterday is that this guy right here is technically our k value. And what we should have concluded also that this guy right here, bless you, this guy right here, if you think opposite of it, that is technically your h value. So the h value right here is minus 1. So the only thing missing right now, I mean, we know that the value down here that's being added or subtracted with x is technically our h. That's where we get our h from. And we know that this value being added or subtracted at the end, that's our k, similar to over here where it's being added or subtracted at the end. That's your k value. What's missing is the a. Okay, so a is always at the beginning of any type of function. So even in this situation, the a is at the beginning. So what we have here is y equals, we're going to have an a at the beginning, and then we have the parent graph that we've been talking about, the 1 over x. But we do have a minus h down here with the x. And we also have a plus k out here after the actual fraction. And whenever you do have a number times a fraction, like if you had 3 times 1/5, the answer would be 3/5. If I had 2 times 1/7, the answer would be 2/7. You just multiply that number times that 1 in the numerator and you put it up there. So the actual form of reciprocal functions that we want to get used to is this: y equals the fraction, the a value up here instead of the front, and then an x minus h, and then the plus k out here. So this is what we need to get really comfortable with. We need to memorize that. Okay? So if you have your notebooks, I would definitely copy this down. Okay? So kind of like back in semester 1 where we said all vertex form parabolas, we have to memorize this. Today on reciprocal functions or type of hyperbola, we got to memorize this form right here. Now, as you guys are writing this down, I want to let you know that a, h, and k are the same identical things that they used to be back with parabolas. What do I mean by that? The a used to tell us whether it gets vertically stretched or compressed. It also tells us whether it gets reflected over the x-axis or not for parabolas. Same deal here. The a value tells you if it gets vertically stretched or compressed, and also if it gets reflected over the x-axis or not. Okay. The h was the shift left or right. Think opposite of what you see. The k was a shift up or down. You take it for what it is. Down here, same deal. think opposite of what you see, and the h will be whether it shifts left or right, and the k, take it for what it is, and it'll tell you if it shifts up or down. The only difference, or the major difference between parabolas and these reciprocal functions, is that on parabolas in vertex form, the hk was the vertex, the most important point. And down here, in our reciprocal form function, what's really important is our asymptotes, all right? The asymptotes. So there's going to be two asymptotes for every reciprocal function that we graph. There's the horizontal asymptote and the vertical asymptote, okay? So the vertical asymptote, actually I'll just put vertical and that's it. The vertical asymptote is the equation x equals a number, and in this case it's going to be the number h, okay? The horizontal asymptote is going to be the equation y equals k. So this is what's important right here. And in addition to that, we need to understand that the hk, it doesn't give us a vertex because it's not a parabola, but the hk really do give us our asymptotes. The vertical asymptote, the one that runs up and down, will be x equals h. Vertical asymptote is x equals h. The horizontal asymptote is y equals k. Now, once you know those asymptotes, you're going to be ready to graph. And it'll be even easier to graph on paper than on Desmos, believe it or not. Okay? But before we get to actually graphing this stuff, well, let me ask you this. Have you copied it down already, this information? So, I mean, we could go through the book, and it tells us, you know, that reciprocal functions are really hyperbolas, and they go through that parent graph, and there it is. If we to the next page, we have more graphs and their functions of these reciprocal functions. Let's take a look at this one. Let's just do a little exercise here. What are the asymptotes? What are the asymptotes? So you have to have two of them. There's a vertical one and a horizontal one. Could somebody give me either one of those, the vertical or the horizontal? Okay, so how about this? What is the vertical asymptote? X equals h, right? Okay, so what is x equals h? What is h? Positive 3. Okay, for h, you always think opposite of what you see. Now, I did do a squiggly underline right there. That minus 3, the h is really a positive 3, right? Now, you could have just told me the vertical asymptote just by looking at the actual function by thinking opposite and saying x equals that guy. Or you could have also said, well, which vertical line doesn't cross through the blue graph? The only vertical line that doesn't cross through the blue graph is the vertical line that goes right through x equals 3. Right? They both infinitely approach. They both infinitely approach, but they never actually touch. Right? So there's your vertical asymptote. The vertical asymptote, you can't just say 3. You have to say the equation x equals 3. X equals 3 is a vertical line. 3 is just the number, right? Okay, so what about the horizontal asymptote? And you can't just say 0 because 0 is a number, right? You want the horizontal line. So what equation will give you a horizontal line? At 0. Y equals 0, right? So you also have y equals 0. That's your horizontal asymptote. Okay. If I asked you for the domain, what would you say? And you got to say x equals all real numbers, but x cannot be 3. How about the range? Y equals all real numbers, but y cannot be 0. Cool? So, moving on in the book, you will see that they end up what you guys just wrote down. F of x equals, they put the a as a numerator, x minus h plus k, right? So just like before on parabolas, a tells you if it gets reflected over the x-axis. H is a left-right shift. K is an up-down shift. Think opposite on H. Take K for what it is. Same exact deal here, okay? So what I would like to do right now is to go to Desmos. So I'm going to put this to the side. Go to Desmos, and let's type our parent graph, y equals 1 over x. Okay, type that in, and you should see this right here, y equals 1 over x. You may need to zoom in a bit, so it's going by single units instead of 2. Because if you go to Desmos, it'll go 2, 4, 6, but zoom in a little, and you'll see the single units. So what I would like you to do is to go back to the parent graph, and let's put, instead of an a value of 1, go ahead and put a 2 right there real quick. Instead of a 1, change that 1 to a 2. And what do you see happen to the graph? You might want to change it back to a 1 and then change it back to a 2. It expands, okay. It expands, would you say up and down or left and right? Bless you. All right, how about this? Do me a favor. Go back and erase that 2 and change it to a 5. So compare the original one, y equals 1 over x, to this new a value of 5. What's happening? It gets further away from the origin. It gets further away from the x-axis, right? So just like before on a parabola, do you guys remember parabolas where you had y equals x squared? That's your regular U-shaped curve. What would happen if you put a 5 in front of the parabola? Like here's your regular parabola. But what would happen if you put a 5 in front of that parabola? It gets vertically stretched. And that's exactly what's happening here. When you change the a value to a 5, it gets vertically stretched by 5. So let me actually show you those graphs that you should have been comparing right now. Here's my parent graph. Here's changing it to a 2 and changing it to a 5. And here are the graphs themselves. So you should see the red one's the parent graph. The red one's a parent graph. So I'm just going to go to this location and that location. Now, when I increase it to a 2, it gets further pulled away from the x-axis. So it gets vertically stretched by a factor of 2. Okay? Or if you were to change it to a 5, then it gets vertically stretched by 5. Make sense? So just like before, the a value tells you if it gets reflected or compressed. Right here, it still tells you, not reflected or compressed, stretched or compressed. Right here, it still tells you if it gets stretched or compressed. Now, if you were to go back to the original y equals 1 over x and put a negative sign right in front of it, what's going to happen? It's going to reflect over the x-axis. Just like before, if your a value was negative, the parabola opened down and got reflected over the x-axis. Right here, put a negative in front, or it doesn't have to be in front. It could also be up here at top. Put a negative on that 1, on that a value, it's going to reflect over the x-axis. So what used to open, down here and over here. With that negative 1, it'll reflect over the x-axis, opening up there and down there. So the red one would be the reflection over the x-axis. Okay. Let me actually show you a picture of that. And also, I want you to check this out. This negative 1 is going to cause a reflection that I was just talking about. When you have a negative 3, it's not only a reflection, but it's also a vertical stretch by 3. And right here, it's a reflection, and since it's a value less than 1, is that a vertical stretch? That's a vertical compression, right? Of 1/10 or of 0.1. So when we take a look at this, it's no longer down here and up there. It's no longer like this on quadrant 1 and quadrant 3. It got reflected. So all of these, because they're all negative, they're up here in quadrant 2 and quadrant 4. Does that make sense? Okay. And of course, your blue one was the original parent graph. So if I'm here, and you stretch it to a 3, it's going to vertically stretch to a 3, right? Going back to the blue, if you compress it to 1/10, it's going to compress vertically to 1/10. So I hope this gets you a better understanding of how A, H, and K affect your graph, okay? So once you get comfortable with the form that you guys copied down in your notes right here, you should be able to graph this or identify the correct graph even easier than graphing with Desmos. All right, let me show you how easy this is. Let's do a XY plane, just a sketch. And what information do I get from this? Do I know my H value?
Yes.
What is it? 4. Now, the H value actually gives us the vertical asymptote. So what would the equation be for my vertical asymptote? X equals 4, okay? So because my H is 4, I know that my vertical asymptote will be X equals 4. Let's actually draw that. 1, 2, 3, 4. Vertical asymptote going right through it. Yay? Okay, now the other one, what's my K value? 2, and what does that give us really? That gives us the horizontal asymptote Y equals 2. And when we go to the Y value of 2, and we draw that horizontal asymptote, there it is. Yay? So these are the most important values of this reciprocal function, or of any reciprocal function. Identifying your asymptotes are the most important part of graphing it. Why? Because you know that, well, first of all, the original parent graph, it was down here and up here, right? Lower left, upper right. If it's negative, then it'll switch. It'll flip, but it's not negative. So I just leave it there, right? And with these asymptotes, the graph is already done. What do I mean by that? You're going to draw an arrow on that green asymptote line. You're going to draw it like if it's actually on it, but you know it's never actually on it. It just infinitely approaches. And as you approach the blue asymptote, you got to curve away from it. And then you draw it like if it's actually touching, but we know that it doesn't actually touch. It just infinitely approaches. Likewise up here, you could draw it like if it's actually on it, but we know it doesn't actually touch. It just infinitely approaches. As it comes down towards the green, it has to pull away, and then it looks like it's touching the green, but we know that it never actually touches, just infinitely approaches. So once you got those asymptotes down, the graph is pretty much done for you. All you got to do is think about the A value. If it's negative, yeah, it gets reflected over the x-axis. So it would be up here and down here if that would have been a negative 2. What does the 2 actually do? The only thing that it does is that it vertically stretches it so the curve is a little bit wider. As opposed to a 1, it would get a little closer to the blue before curving up. But a sketch, this is already good enough, a perfect sketch, okay? So, and you don't have to do any math, it's just identifying your 2 asymptotes, drawing your asymptotes, and then understanding how A affects it. Let me, well, actually, so a question on the quiz could be, I could give you this function, or actually this function right here, and then say, what is the vertical asymptote? You're going to have to say X equals 4. What's a horizontal asymptote? You'd have to say Y equals 2. I could say, what's a domain? You would say X equals all real numbers, except for X cannot be 4. The range, Y equals all real numbers, except Y cannot be 2. Right? So those are all questions I could ask on the quiz. I could even ask you to identify the correct graph just based on this. And if you understand A, H, and K, it should be easy to identify that correct graph. So we have a homework assignment. We're on page 549, which you guys don't even have the books. You're going to have to go to page 549 on the PDF that I have attached on today's Google post. And we're doing 7 through 15, and then we're skipping to 19, 21, and 22. But look how easy this is. It says identify the asymptotes, the domain and range of each function. I want to do one of them for you. Let's do number 10. So identifying the asymptotes, the domain and the range, you could do this visually or you could do it numerically with the actual function, right? So what are the asymptotes? And in the book, it doesn't say vertical or horizontal. I'm saying vertical. What is a vertical asymptote? X equals 1. Okay? Now you could have done that visually and said, okay, this guy is approaching, well, it doesn't go to 0, but it looks like it's approaching halfway. And halfway would be the number 1, right? Likewise, this one, it passes 0, but it doesn't go to 1. It actually approaches that halfway point. So the halfway point, which is the actual numeric value 1, that'd be your vertical asymptote x equals 1. But I would even go easier looking at it numerically. What's your h value? Your h value is positive 1, which means that your vertical asymptote is x equals positive 1. Remember, the vertical asymptote is x equals h. So the h is 1, so your vertical asymptote is x equals 1. So you could look at it and be like, okay, what value is this? But even easier, what value is that? That's 5. So what is your horizontal asymptote? Horizontal is going to be y equals 5. So those are the two answers that they're asking for. What about the domain? X equals all real numbers, but x cannot be 1. The range, y equals all real numbers, but y cannot be 5. That's it? Yes. So that's ridiculously easy, I would say. And the second part of the homework is where they actually want you to graph the function, then state the domain range. But graphing it is as easy as identifying your asymptotes, sketching them, and then thinking about your a value and see how it affects it. So let's do the last one here. What are the asymptotes? Anybody? What's the vertical asymptote? X equals 2. So if I go 1, 2, and do a vertical asymptote, right? And then what's the horizontal asymptote? Y equals just 2, right? So you go to 2 on the y and draw that horizontal asymptote right through there. Okay? And now, normally I would draw it like this and like this. Okay, so I'd have it up, down here, lower left, and upper right if the a value was 1. But the a value here is negative. So instead of down here and up here, where's it going to be? Reflected up here and down here. Does that make sense? Okay. Now the only other detail is the 5, but when you're sketching it, it's really not that big of a deal. We know that we're going to draw it like if it's actually on the green line, even though we know it's not on the green line, it just infinitely approaches it, and make it a wider curve like that. Wider curve like that. Now, why did I go with a wider curve? Why didn't I get closer to the red before turning? Because it got vertically stretched by 5. That's why it's a wider curve. So if it would have been a regular -1, it would have gotten pretty close and then turned. But because of the 5, it got vertically stretched, so it's a wider curve out. Does that make sense? Okay. And a final skill that I want to ask of you on the quiz Friday is to describe the transformations from the original to the current graph, from the parent graph to the current graph. So you would say, like, the first thing that happened, by the way, we're working on this tomorrow and the next day. It's not part of today's homework. But the first thing is that it gets reflected over the x-axis, then it gets vertically stretched by 5, and then it gets shifted 2 to the right, and 2 up, because you got to think opposite of what you see here. And that's about all that there's going to be on this section, right? If you understand this, you're ready to go. Of course, you still need to review adding, subtracting, multiplying, dividing fractions that we learned previously. But that's about it. So I'm going to give you the rest of the class to work on these questions. Please don't waste time. Remember, if you're watching me and understanding, that's great. But that's the equivalent of going to the gym and watching somebody work out. You're not going to get stronger unless you actually lift the weights yourself. So right now it's time to lift weights. Math weight in your brain. Let's get our heads buff. Okay.